This is our review for our Chapter 8 test. It will be over sections 8.5 to 8.8. The directions will simply say factor completely. So we are going to be factoring polynomials. And the first thing we want to do is ask ourselves, what does this polynomial look like? We have 4 scenarios. They're covered in your chapter notes and in each of the sections. So the 4 scenarios, what we're going to do our initial assessment on is, are there 4 terms? If so, we're going to factor by grouping, like section 8.8. If it is ax squared plus bx plus c and a equals 1, we're going to factor our c to combine for our b, like we did in section 8.5. If it's ax squared plus bx plus c and a does not equal 1, we're going to do split the middle, like we did in section 8.6. And if there are only 2 terms, we are going to check for difference of squares, like we learn in 8.9. So these are the 4 different scenarios for your Chapter 8 test. You have to learn how to address each one. So let's look at our first example. 18g cubed minus 33g squared plus 30g minus 55. This is an example where our polynomial has 4 terms. We know we are going to factor by grouping. That's how we're going to attack this particular problem. So the first thing we do is we say, is there a greatest common factor we can take out of the whole thing? For this one, there is not. So we group our first 2 terms together. 18g cubed minus 33g squared. What can I factor out of there? A 3 and a g. And when I factor that out, I can factor out a 3 and a g squared. When I factor that out, I'm left with 6g minus 11. Now remember, I write that 6g minus 11 right away on the right side, and I use that to help me figure out what I'm going to factor out. In order to get from 30g to 6g, I have to factor out a 5. Then I make sure that works for my last term as well. So that negative 55 at the end, if I divide that by positive 5, I am left with a negative 11. So that means my terms are factored correctly, and I rewrite my answer, 3g squared plus 5 times 6g minus 11. So there's our example. 4 terms, I factor by grouping. Our second example is this y squared plus 3y minus 54. This example is not 4 terms, it's 3 terms, and a equals 1. This means we are going to factor the way we did in section 8.5. All I have to do is find the factors of c, in this case that's 54, that have a difference of positive 3. So let's remind ourselves how we know that, okay? When we're looking at these equations, sorry, I have to switch places here. When we're looking at these expressions, okay, we can read them, right? I start at the c term. When a is 1, I know all I have to do is find the difference of the factors of 54, and I know it's a difference because it's minus 54. I have to find the factors of 54 that have a difference of positive 3. And I get positive 3 because that's my b term. So I factor 54. There are my factors of 54. And I ask myself, which ones have a difference of positive 3? And that would be negative 6 and positive 9. So there are my 2 binomials. I split that y squared into y and y. It's the only way to factor it. And then I put minus 6 and plus 9. And I'm done. Now remember, I could check this. Y times y is y squared. Y times 9 is 9y. Negative 6 times y is negative 6. Positive 9y and negative 6y gives me that positive 3y in the middle. And negative 6 times positive 9 is negative 54. So I checked my work, I'm done. Third example, we have 24n squared plus 2n minus 12. Is this 4 terms? No, so I'm not going to factor by grouping. Does a equal 1? Unfortunately not, so I can't just split it up right away. So I am going to split the middle. That is how I'm going to attack this problem. Now with all these problems, we ask ourselves, is there a greatest common factor that I can take out to make my number smaller and make my life a little easier? And the answer for this one is yes. I can take a 2 out of each one of those factors. So I take out a 2 and I'm left with 12n squared plus n minus 6. Now this is the one I'm going to split the middle. So I multiply a times c, and in this case that's 12 times 6, and I get 72. Now I can still read this equation to help me know what I'm going to do, what factors I'm going to use. I say I'm looking for the 2 factors that have a difference. I know it's a difference because I see that minus 6. A difference of positive 1. I know it's a positive 1 because my b term is plus 1. So again, I need the factors of 72 that have a difference of positive 1. So here are my factors of 72. The ones that have a difference of positive 1 would be a negative 8 and a positive 9. So now I split the middle. And split the middle, the idea is now I rewrite my 3-term polynomial, my 3-term trinomial there, into 4 terms. So I have 12n squared, that one stays the same, but instead of writing plus n, I write minus 8n and plus 9n, and then minus 6 stays the same. Now I have 4 terms, that means I must factor by grouping. So notice that 2, that greatest common factor that I took out at the beginning, that stays up front by itself. Now I factored these 4 by grouping. So 12n squared minus 8n, I'm going to take out a 4 and an n, and I'm left with 3n minus 2. I rewrite that 3n minus 2 on the right side, and I say, how did I get from 9n down to 3n? I factored out a 3, and I check to make sure it works for the next one. Negative 6 divided by positive 3 does give me a negative 2. So my factors work, and I rewrite my answer. There's my 2 out there at the beginning, and my first binomial is 5n plus 3. My second binomial is 3n minus 2. Done. Our last example is from section 8-9, and these are called special cases. And the special cases I want you to watch for are whenever there are 2 terms, okay? So if I have 2 terms and I want to factor it into 2 binomials, there has to be subtraction between those 2 terms, first of all. I can't even consider making 2 binomials if it's not subtraction, okay? So for this first example, 28y squared minus 28, I'm going to look and see if there's a GCF. In this case, there is. I can take out 28. So I do, and I'm left with y squared minus 1. Now I ask myself, is this a difference of 2 perfect squares? Is y squared a perfect square? Yes. Is 1 a perfect square? Yes. Is there a minus between them? Yes. So that means I can factor this into 2 binomials. I take y squared and I say y and y, the only way to factor that. And then I take the 1, which is a perfect square, and say that is 1 times 1. So notice when I factor this, y squared minus 1 into y plus 1, y minus 1, y times y is y squared, y times negative 1 is negative y times positive 1 is positive y. Those cancel each other out, because negative y plus positive y is 0. Then I'm left with 1 times negative 1, which is where I get that negative 1. Okay, so that is factored. You might also see 2 terms that are not factorable. If there's a plus in the middle, this x squared plus 25, that's not factorable, okay? There's no greatest common factor I can take out of there. And unless it was a minus, even though x squared and 25 are both perfect squares, I can't factor it. So that is not factorable. This last example has a plus, okay? But it does have a greatest common factor, so I can at least factor out that 4, leaves me with x squared plus 3, and that is not factorable. There's nothing I can do with x squared plus 3. So again, this last scenario, if I have two terms, if I have two terms and there's a subtraction, I want to check for difference of perfect squares. If I have two terms and there's not subtraction, the most I can hope for is to take out a greatest common factor, or I may be left with something that isn't factorable. Okay. All right, that is your wrap up for chapter 8, sections 8.5 through 8.8. Again, remember back at the beginning, we have an example of each one. But again, our summary is, in order to factor for your test on chapter 8, you're first going to ask yourself, what does it look like? 4 terms, I'm going to factor by grouping. A equals 1 for ax squared plus bx plus c. I'm going to use 8.5 where I just factor c to find b. Ax squared plus bx plus c, where a is greater than 1, it doesn't equal 1, it's bigger, I'm going to split the middle. And then the last scenario, if there's just 2 terms, I know I check for difference of squares or just take out any greatest common factor I can. Good luck, guys.